Okay, so let's get started. First of all, welcome to this course on mathematics for data science. So essentially, as the name indicates, we will try to study some of the tools that are essential to data science, mathematical tools that are essential to data science in this particular course. So let me start with a few logistics. All of you can hear and see the screen, right? Hear me and see the screen? Yes or no? Okay. No, not the TS. I mean, okay, fine. Okay, so let me start with a few logistics. First of all, there are four TAs to this course, out of which one will be there till the end of this month. So three will be there for the rest of the classes. So you can bug them anytime. So four TAs. The other logistics include, for example, how do I evaluate your performance. So this is something that you should wait till tomorrow. I will let you know by tomorrow how I am going to evaluate what is the grading policy. So the third thing would be the course content, which is there online, right, Chandan? It should be on. It's there online, right?
Yes,
Yes,
sir.
sir.
Okay. Okay. So let's get started then. Okay. So how many of you are on offline, or how many of you are not there at IIT Dharwad? This will help me conduct the course in a mixed mode appropriately. So how many of you are not at IIT Dharwad? Don't hesitate to speak up, please. Okay. Pratik, two, only two, only two students. Okay. Okay. Okay, so let's get started. Can somebody tell me what is the difference between, for example, data science and machine learning? So, what is the difference? Right. So, many of you might have heard of machine learning. You would have taken some courses during the summer. So, what is the difference between data science and machine learning? Can somebody tell me the difference? Yes, somebody can tell me the difference. Nobody wants to speak. Can you guys hear me or no? I mean, hello.
Sir, just a small try. In machine learning, we use the different algorithms to get our result in certain means certain results that we are expecting. And in data science, we play with the data that we have. Different mathematical modules, we try on it to find something meaningful out of that data.
Okay, you don't do that in machine learning.
So means in machine learning we use predefined algorithms or means we don't explore that much the data. The goal is already predefined. We just reach our goal.
Okay, can somebody else answer? I mean, any thoughts on this? What is the difference between data science and machine learning, or what is the relationship?
So the machine learning is basically, if it's a supervised, it's a mapping from X to Y. Whereas data science, you extract the statistics from the data to means to get some idea about the data.
Okay, so any other comments? Okay, if
Sir,
not,
maybe
yes,
data
yes.
science is the analysis of data after creating certain machine learning models.
Uh, okay, any other answers? Okay, so let me answer. So, data science, as the name indicates, you use the data to take some meaningful decision. For example, let's say you are looking at some stock values. That is your data. You want to do some investment, and you can make uh, a, an informed or make a proper decision based on the data. So the tools that you use in order to do that is what data science is all about. So what is machine learning? You essentially do same thing, but it's a specific set of tools that you use in order to do that. Okay, whereas data science is much broader. So it's, if you want to pictorially represent this is your data science, and somewhere here you have machine learning. Okay, so it's a part. For example, the data analysis course that you took in the second year is all about how to get some meaningful insight using the data, right? You use a lot of statistics, etc. So what you do in machine learning is you do similar things, but use a different set of tools, for example, neural networks and so on. Okay, so anyway, so this is the difference. Although many of my examples will lie in this field, machine learning, but I'll try to give a few examples in data science as well, in general. Okay, so let's get started. So let's start with the first example. This is this class is all about motivation and giving you the big picture of what this course is all about. So I won't immediately start the core of this course. That I will do from next class, or perhaps the end of this class. So let's look at the first example. Okay, so this is something that you would have seen the moment you Google machine learning. There will be examples which are very similar to this. So the first example would be, let's say I want to, the problem is the following. So finding the expenditure of a house. Okay, so what do you mean by this? Well, for example, you go to a house. How do you value a house? On what basis? How do you, for example, if there is a house, what are the characteristics that will that are proportional to, say, for example, the value of a house? What are the things that you will ask? So, for example, okay, so first thing would be area. Fine. Area of the house. Okay, number of rooms. Okay. What else? What else?
Reachability.
Okay, so reachability, you can measure it in different ways, right? For example, you can say the nearest bus stop, right? Distance to the bus stop or something. Okay. Bus stop. Okay. What else? And so on, right? Area means the size of the house. Maybe I'll also write that size. Okay. Area could be in which area the house is located, right? For example, if it's in some posh area, the rate could be very high, and so on, right? So these are certain features that will tell us what is the price of the house, right? So you use this to predict the expenditure. Is this fine? Clear, right? It's very obvious thing that anybody will do. So how do you find these characteristics or features? Well, you go to a real estate person and ask him what are the typical things that you should consider in order to predict, or in order to find or let's say not the expenditure. I think, I'm sorry, this should be the price of the house, right? Not the expenditure. Okay, so this will be the price of the house. Well, you can also do expenditure, right? Depending on where the house is located, how many people are there, what is the rent, etc. Right? So that's a different problem. So let's assume we want to find the price of the house. So these are the characteristics, right? So now, what is it that we want to do? If you want to mathematically represent this, so I cannot. Typically, what people do is some of these features, right, need not be numbers, right? It could be, for example, if you want to say what is the area, you would say Jayanagar or something, right? You won't really, there is no number attached to it. So the first thing people typically do is you have to attach a number, right? So how do you attach a number? Maybe you give rating, right? 0 to 1. So 1 means very posh area, 0 means, let's say, some very bad area, and in between, right? So you can use numbers. So essentially, if you collect all these features, what do you get? You get a vector, right? X1, X2, and so on, Xm. So you get M numbers, right? X1 could be the price of the house, X2 could be the size of the house, Xm could be the locality or area, whatever you want to call it, right? So mathematically, you will get a vector, right? So you want to map this vector to let's say up the price of the house, right? Let me call y. This is the price, right? So all that you have to do is, given these m numbers or a vector, you have to find a number called the price. So where this number lies? So this number lies in r plus, right? So that means it's a positive number, right? You cannot say the price of the house is -1 lakh, right? So this is what the task is. Given a vector, I have to find a map f that will give me the number. So basically f of, if I call this as capital X, f of x will give me a number called the price. So these are called features. So now, of course, this is a big picture of how do you find the price of a house. So suppose, let's say you want a machine to do that. So what is it that you will do? So of course, we need to make some assumption. For example, I say that, this is the assumption, or this is a reasonable assumption to make. So what is that? Let's say the price is some linear combination of these features. For example, I say y is some w1 x1 plus w2 x2 and so on wm xm. Okay, so is this always true? Can I make this assumption? The price of the house is always a linear combination of the components of the feature vector. Can I make this assumption? Yes or no?
No, sir.
Yes.
No, sir.
No, right? This is in general need not be true, right? Our model assumption is not very accurate. So because of which we always have some error, right? Let me call this error as W. Okay, so this is my error in my assumption, or error in my model, right? So but this is a simplifying assumption, right? So I can just say the price of the house is a linear combination of all the feature parameters plus some noise which will characterize how much I am deviating from my assumption, right? Okay, so now suppose this is the model and I want to find this f, which will tell me given a feature. So what is f now? F will be what? So in some sense, I can call this as my f, right? So this whole thing is f of capital X, right? Can I call this as f of x? So essentially the price is f of x plus noise. Well, I want to find this f, right? But in general, I want to find f that will give me the actual price, but that is very difficult in practice because there is no guarantee it's linear combination. There is no guarantee it's some polynomial combination and so on, right? So always you make a mistake. So let's stick to the simplest possible f that you can have. So this is f being linear, right? So this is a linear f that I'm looking at. Suppose this is my assumption and I want you to find f. So how would you go about finding f? So what do you think is the step that you will, or what is the procedure that you will follow? Yes? Any idea?
We'll do regression. We can do regression.
In order to do the regression, you need something, right? So you do regression on what?
With the cost function.
That is also fine. Let's say I give some cost function and all that, but the first thing that you need is data, right?
Measuring that.
No, but you need some data, right? So you need to find the pattern here, right? So of course linear pattern, but you need more data in order to figure out what will be the pattern. Do you agree? It's good to have more data, right? So anyway, so I can also write this y as follows, right? This is W transpose X plus noise, right? So I think I have used the same. I'll use n here, okay? N for noise. Okay, so this is simpler notation y. So this is all that I'm doing is this W1, W2, Wm, and this is X1, X2, Xm, plus one number noise, right? So this is what we have. So now, if you have to solve the problem, of course, what is the problem here? The problem is The problem boils down to find W, right? If you find W, you're done, right? You give me X, I'll say W transpose X. That will be my whatever the price, right? So what do you do typically? So what is given? So you are given lot of data, right? So you are given the following data. So let's say you go to house 1, collect all the features, right? Let me call that vector as x1. So x1 will give me the area of the house, the locality, etc. That vector is x1, and also they will give me what is the price. I go to house 2, x2, y2, and so on. I collect, let's say, n data points, right? Suppose. Now, given this set of data points, what should I do? I should find the function f, or in this case, simple linear function, which corresponds to finding w, such that your prediction is as close as to your actual value as possible. So, right, what is the problem that you will pose given this? What is the problem? Given n data points. Suppose, let's take a very general approach, okay? So suppose, let's say f of, I want to find f, right? So f of x1 should give me what? What should it give me? Suppose you're finding a map from the feature to your price. So what should f of x should give you?
y1 minus noise.
House price.
Well, ideally, I want this to be y1, right? Let's say f is designed by God and he knows everything, assuming that is true. Then f of x1 will be y1, f of x2 will be y2, and so on. He will find such an f, right?
Yeah.
Right? But in general, I want f of xi to be equal to yi. Well, is that possible? Not really, right? In practice. So I want the difference to be small. In other words, I want the difference squared to be small for each I. Well, what I will do is I will sum it over all I. Okay, so how many i's are there? I mean, how many terms are there? N terms, right? So I want this squared error term, the square sum of the squared errors, to be as small as possible. How do I do that? I'll minimize this overall f. Okay, so this f, right? So what does this give us? This gives us some f star, right? Or let me call this as f hat star, right? It will give me a function which is f hat star if I do this, if I solve this problem using the data. So how do you predict? Or suppose I give you x, how do you predict? Y hat is my predicted price, which is f hat star of x, right? So this is what I do. X is my input, that is the feature corresponding to a new house. Then I will just take my f hat star that I have computed. I'll say f hat star of x, that will be my price, right? Is that fine? Again, recall, this is called a feature, right? Feature vector. Okay, so solving this problem, this problem here is called a regression problem. Okay, this is called a regression problem. Okay, so I'll pause here for some time, maybe a couple of minutes. Any questions? Questions? Yes. Any questions? No questions? Is it boring? First class itself is boring. Okay, how many of you think that it's very boring?
Hello,
Yes.
sir. So why do you take a square in the error and why not just a simple difference?
Oh, the simple difference, what can happen is something can be positive and some other thing can be negative and you get a 0, right? Or you can get negative also. You understand what I'm
Yes, sir,
saying,
but
right?
we could the modulus and we could use a modulus. to
Right,
get
so that's a
absolute
good
value.
question. So why not mod in terms of instead of squared, right? Okay, so can somebody tell me what is the difference between mod of x and squared? Let's say mod x versus x squared. let's look at it from a calculus viewpoint, right? You have taken calculus. So what are the differences,
So mod x will not be differentiable, but x square can.
right? So mod x is not differentiable everywhere, or where is
Sorry,
it
sir?
not differentiable?
At 0, sir.
At
At
0,
zero,
right?
at zero.
So x squared is differentiable everywhere, right? So that is one reason. X squared is well behaved, right? And what is the other thing? So x mod x, if you look at it, the function looks like this, right? This is how mod x looks like. How does mod x squared look like? Something like this, right? Even here it will be like this. So that means for smaller values of x, for example, x between 0 and 1, x squared is smaller than, well, I may not have written it to the scale, but x squared is smaller than 1, right? Much smaller. For example, 0.1 squared is 0.01, right? It's 1/10. So it's very small. But if you make it very large, for example, 100, it will be 100 square, right? Which is 10,000. So in other words, it will amplify larger differences. It will smaller differences, it will not amplify. It will do the exact opposite, right? So whereas mod x, it will give as is. So it's better to use x squared so that it will penalize larger values, right? That's another reason. The third reason is mostly historic, right? So where have you seen this kind of problems? Are you, who asked this question? Surya Vijay, right?
Yes, sir.
So you are from which department?
Electrical.
Electrical, right? So can you tell me where else you have seen these kind of problems? Hey, you are from electrical background. You should know where these kind of things will occur, right? Others can also answer.
Sir, I cannot recall at the moment.
No, when do you have the square terms and all that? Squared in electrical engineering, for example, what does that signify, right? It in some sense signify power, right? You always have the squared and you integrate, that gives power, right? So it's for some historical reason. People generally look at squared. Mod x will always give you a slightly complicated result. So still, in many cases, you can handle it, but typically it doesn't give you a very nice. It's not as easy as squared. For example, if I want to take the derivative of this, it's 2 times x, right? Done. What about mod x? For x equal to 0, I don't know. There is no, it's not differentiable. For x greater than 0, it's 1. X less than 0, it's -1, right? I have to do a lot of bookkeeping in order to handle that. But square is kind of good. I hope the justification is good enough. Okay? Not that you should always use squared error. When you can use mod, you can use some other function of the difference and so on. But typically in regression, we use squared error. Did I answer your question, Surya Vijay?
Yes, sir.
Okay, I think I asked another question. Is it boring? How many of you think that's boring? No one? Or how many of you think that I don't care? Okay, so looks like you don't even care about my questions, let alone the course. Okay, so let's move on. These problems are called regression problems, right? So what is the first mathematical tool you need in order to do this? For example, I need to solve this problem, right? So in order to solve this problem, you need the first tool, which is called what? Can somebody tell me? It's optimization, right? So optimization is basically maximizing a function, minimizing a function, and so on. But it's not as simple as that. You may have some constraints also. We will see what that means later on. So we need optimization as a tool in many of the data science related problems, and that is one tool that we will study in this particular course. Of course, in order to look at these functions and derivatives and so on, you also need calculus, right? Especially multivariate calculus. So we will briefly look into it. Particularly, we will look at certain things like limits. We will look at, for example, continuity of a function. right? And so on. So these are some of the topics that we will look at in order to solve some of these problems. Okay. Okay. So now let's look at the second problem, which has got something to do with the matrices. Okay. So let's look at this problem. Okay. Example 2. So this problem is about movie ratings. Okay. So how do you rate? What is this problem? So essentially, when you rate a movie, for example, you have users. Let's say user 1, user 2, and so on. There are, let's say, user n. Okay, so there are n users who are watching movies on Netflix or whatever, and there are so many movies, right? Movie 1, movie 2, and so on. Let's say there are m movies. Okay, so now what happens is, each time a user watches a movie, he will be asked to rate it. Let's suppose he rates it. For example, user 1 watches movie 1 and he gives a rating y11, meaning let's say rating is from 0 to 10. If he thinks that the movie is very good, he will give 8 or 9 or something. If he says it's okay, watchable, then 6, and so on, right? You know what that is, right? And I will scale it by 10, so I get a number between 0 and 1. So suppose y11 is a number between 0 and 1. That's your rating. And obviously use all, every user cannot watch all the movies. Maybe, user 1 haven't watched, let's say, movie 2, so it's blank. I'll denote it by star. Star means he has not watched that movie. Let's say he has watched the mth movie, and the rating is YIM, and so on. Okay, so let's say this is again star, and he has watched the next movie y12, and so on, and then star, and so on. Okay, so you know how to fill this matrix, right? This is the movie rating matrix. Okay, now suppose, let's say, user 1 is a friend of user 2, let's say close friend, and they have similar tastes in terms of watching movies. So the ratings will also be similar. Do you agree with that? Yes or no? Right?
Yes, sir.
Right. Okay. So supposing I make that assumption, in this group of users, there are several users who are very much closer to each other in the sense their tastes are, similar. So given that, can you, so this is an incomplete matrix, right? So this is an incomplete matrix, right? In fact, you can think of it as data. Now I have to complete it, right? So meaning I have to tell what is user 1's rating for movie 2. If I have to say that, right? Suppose the rating turned out, if I fill this matrix and the rating turned out to be 0.9, let's say, on a scale of 1, then I should recommend this to user 1, and user 1 will watch, and therefore I can make a lot of money, right? So everything boils down to money, right? So this is why these kind of problems are very important. So now you have to fill in these gaps or missing data. Or this problem is called matrix completion problem. Okay, so matrix completion problem. How many of you have heard of this? How many of you have heard of this matrix completion problem? No one? Okay, so there are quite a few people who have who knows what matrix completion problem is. Good. So this is what matrix completion problem is. You have to fill in all the ratings so that you can recommend good movies or not recommend bad movies. So now, how do you fill this? Well, in some sense, it's impossible to fill, right? Unless you make some assumptions. So what is the assumption? There are users who are similar, right? So let's say similar users. What do you mean by similar users? Well, for example, the ith user is similar to jth user. So what do you mean by that? So if you look at the vector corresponding to ith row, right, and vector corresponding to jth row, that is, for example, if you go back, suppose there is ith vector here, that is your rating, this particular rating, okay, and there is a jth user here, I and J. Okay, so this is your, they are very similar, meaning their ratings are kind of aligned. So what do you mean by that? It means I can assume that y1 is kind of related to y2 through some alpha, right? It's some scaled version of the other. So if I know his rating, I can just scale it and get the rating of the other guy, right? In some sense, if you want to geometrically look at it, so for example, yi is this, alpha yi could be something like this, right? So this is alpha yi, which is yj, right? It lies in this on the same vector, right? So now if you have, you know, vectors which are related in this way, linear scaling, what kind of a matrix is this? Can somebody tell me? Those who have taken linear algebra, you have studied linear algebra, right? All the BTech students for sure they have studied linear algebra. So what does it relate to? Suppose I have a 2 cross 2 matrix. I can think of the first row as a vector, second row as another vector. So first row is 2 times the second row. What kind of a matrix is that? Can somebody tell me?
Dependent.
No, these are dependent vectors, right? So when you stack two dependent vectors to make a matrix, what kind of a matrix is that?
Singular
Hmm?
Singular matrix.
What matrix? Can you repeat? Sorry, I couldn't hear you.
Singular, sir.
Singular. Okay, so that is correct. It's a singular matrix. So are there any other jargon or equivalent name? How many of you have heard of rank? Rank of a matrix? No? Okay, good. How many of you have not heard of rank? Okay, let me ask you that. Surya, you have heard of rank or not heard of rank? Surya?
I have heard of rank.
You have heard of rank. So those who have not heard of rank, okay, anyway, so don't worry, we will look at some aspect of it. So essentially what it means is, you know, this this implies that the matrix or the movie rating matrix, right? Movie rating matrix is what is called rank deficient, right? So if I assume that there are too many users who are related to each other, they think alike in terms of movies. So the problem that I would like to solve is the following, right? So what is the problem that you would like to solve? I want to fill in those entries, right? In other words, if I look at the rank of, for example, this matrix X, I'll call this matrix X, okay? So this entire matrix, I will call it as X. Okay, I'll call this matrix as X. So I want to find a matrix whose rank is as small as possible, right? Minimize over all X. Okay, so that's what I want to do. Well, this is if I just give you this problem, the problem is very, very trivial, right? Why? You give all zero matrix, right? That will be your this thing. Or yeah, so but then remember, you cannot give all zero matrix. Why? Because I have entries here, right? Y11, Y12. So you should, those entries should not change. I just have to fill in something that's not, you know, somebody hasn't rated the movie, then I have to fill in those numbers. So now I have to say subject to, that means I want to find a matrix with the least rank. But if you look at, for example, the ijth entry of X, that should be same as Yij. Yij is the ratings given by the user. Whenever Yij is not equal to star, I mean, whenever the entry is there, right, then Xij should be equal to Yij. Wherever the entries are not there, you are free to choose whatever you want, but make sure that the rank is as small as possible. Okay, so this is another example. You know, it gives rise to two things, right? So the first tool is, of course, matrix theory or linear algebra. And you also need optimization here. Well, this optimization is a very complex or a very hard problem to solve. This is what is known as, you will see what this is. This is called non-convex problems. Okay, don't worry about these jargons. You will understand what this means later on. Okay, non-convex problems. Well, matrix completion problem, which is a very practical problem. You know, many companies want to solve this. This problem turns out to be a non-convex problem, and whoever solves it in an efficient fashion will kind of make a lot of money, right? Right. Okay, so now linear algebra optimization is something very important, right? Whenever you deal with data analysis kind of problems. Any questions? Questions, comments? No? So of course, this part of, I mean, today and tomorrow's lectures will be very similar to last year, but you know, subsequently the way I'm going to teach this will be slightly different from how I taught last time. Okay, so I'm sure you will have access to the videos of this, the first few lectures that I gave last year. Okay, any questions? Feel free to ask. Okay, so Swami Vinay is asking, what do you mean by non-convex problems? Well, we will study this in great detail, but I'll tell you what this non-convex problem is. First of all, let me tell you what is convex problem. So this particular function, right? Typically, if you look at any optimization problem, it will be minimum or maximum of some function f of x. So this function f of x, if it's like this, right? It's called convex because, you know, for some reason. Let's not get into that now. Anyway, I'll teach this in greater detail. And the constraint set, right? So if you look at where this xi should lie, the set corresponds to what is known as convex set. Then we say that it's a convex problem. So in simple terms, if the optimization problem is a convex optimization problem, you can hope to solve the problem very efficiently and you get the optimal solution. If it's a non-convex problem, your situation is hopeless. I mean, it's not easy to solve. Okay, for now you can think of the two problems as hard and easy. Okay, convex is easy, non-convex is hard. Okay, any other questions?
So since this problem is a bit complicated, is this the only solution possible, or is there other solutions also to this matrix filling problem?
Meaning what? I didn't understand. So the formulation you are asking, right? Not the problem. So
Like the solution was you gave us to minimize the rank constraint to something. Like,
well,
is there any other solution similar to that?
yeah, so of course you can look at other functions here, right? What you're saying is this is the problem that I posed, hoping that this will fill the missing entries in an efficient, whatever, quote unquote efficient manner, right? But the question is, can I replace this rank by some other functions and still find the missing entries in a very efficient manner? Meaning, let's say those entries are something that I think of, right? I haven't rated the movie, but I do the matrix completion and then I watch the movie and then I feel that, okay, the rating is pretty accurate, whatever I'm going to give. So one can replace this rank by various other things, possibly other things, but this is the most intuitively straightforward ways of posing the problem. Possibly there are other formulations, okay, other equivalent, but many other formulation turns out to be similar to rank only. Okay, any other questions? Did I answer your question?
Yes, sir.
Okay, yeah. Any other questions? Yes. Yes.
Sir, how is rank connected to the optimization set? Means how can we use rank for the optimization?
No, rank is a number, right? Do you agree? You give me, so think of it as a black box. You give a matrix to that black box, it will output a number called rank, right? So now
Yes,
I
sir.
have to think of it as a mechanism wherein I'll keep on entering different matrices and I'll keep on getting different numbers. I have to get the least number. I have to input a matrix X that gives me the least number. But there is a problem. I cannot throw in any matrix into that box. I can only throw those matrices wherein the non-missing entries coincide with the rating, right? So such matrices have to give. You understand what I'm saying? So
Yes,
this is the
like this is
process.
some like cost function.
No, this you can think of this as this is some function, right? So some g of x. Do you agree? It's a function of matrices, right? So I want to find that matrix x that minimizes the g of x, subjected to the constraint that the non-missing entries match. Okay.
Okay, sir.
Any other questions? Questions? No? No more questions?
Sir,
Ah.
with too many few points in the feature vector that are not star, you can't actually try to fill that whole matrix is a matrix of means the feature of that person, right? If I talk about user and movie matrix,
Mm-hmm.
so if a user only watched one or two movies out of like 10 of thousands of movies,
Mm-hmm.
you can't claim to by using any algorithm you can't claim to that after just 2 points from that feature vector you can't
But
fill the whole feature vector, right?
the number of people will also be very large, right? Much larger than the movies. For example, there is, let's say, 50 million subscribers, and let's say there are 10 million movies. Now, of course, a single person cannot watch all the movies, but he would have watched a few, right? Maybe
Yeah.
he has watched 100 movies, let's say. So there'll be a non-zero, non-star entries to those 100 points. The next guy will also have a non-star entries for 100 points. So essentially what you have is, okay, so let me write this. So essentially what I'm saying is, for example, you have something, okay, so I'll say A1 star, 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 lot of stars, and then star A2 star, lot of stars, and let's say A3. Okay, this is the first person. The second person could be star, star, B1, star, 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 and so on, star, star, C1, sorry, B2, star, 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 and B3 here, and star, 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 star. Okay. Now, if you consider this as two vectors, right? If this is my matrix, let's say only two people are there, okay, and there are so many movies, and let's say the first person has watched only three, the second also has watched three. Now, if you look at this as vectors, right? When do you think these two vectors will be? If I want to minimize the rank, see these A1, A2, A3 are non-zero, B1, B2, B3 are non-zero. So if I want to align these two, what should I do? See, this can be a scaled version, no problem. This can be a scaled version, and so on. What about this?
They
I can
need
make,
to be
right?
same.
It's a scaled version. I can make this as a scaled version. I can make this as a scaled version. The problem is very, very simple here. This will be, let's say, 0.6 times A1. This entry will be 0.3 times B1, and so on. I can do that. Star, if you have these two, I can just say 1 and 1. Okay, it doesn't matter, right? Any random number or 0 and 0, that will also work. So any number will work, right? So that means there is no unique solution there. There are multiple solutions, right? That's why I said the function doesn't look like this. It will be like,
Right.
now which minimization, which point will you pick? You can pick this also, you can pick this also, you can pick this also, you can pick this, so many, right? And remember, for example, there could be like this also. This minima and this minima are like at the same level. So that means there are two matrices which are equally good, right? So this is the landscape that we'll be looking at. These are the kind of functions that we'll be minimizing right here. So is that fine?
Yes, sir.
Okay, any other questions?
So the matrix that is formed, that will be purely dynamic, because if someone watches the movie and then rates it, then
That's
his
correct.
vector will change from the other person's which we
Exactly.
were
Yeah.
using.
You may have to update the matrices again and again and again. Yeah.
And so if suppose one person has a taste similar to more than one, so
So that was taken care of by the rank, right? For example, let's say three vectors, V1, V2, V3. So if V1 is 2 times V2 and V3 is 3 times V1, then all of them are related to each other, right? That means there are three vectors aligned in one direction. That's what it means. So the rank is 1 for that matrix, right? Anyway, don't worry about those who don't know what rank is or might have forgotten. That's what we will do in linear algebra part. Okay, so let's recall and let's try to understand what it means to say that rank is 1, rank is 2, and all that. Okay. Is that okay, Saurav?
So,
Saurav, right? Yeah.
sorry, I was on mute.
Yeah, your name is very easy to remember. Yeah. Okay. Any other questions? Okay. So let's move on. Let's look at another problem, which is again, another example which is very typical. So typical of machine learning problems. So this is what is known as spam. This is something that I keep on giving to every student. So this is spam versus non-spam problem. Okay. So what do you mean by this? So essentially, there is an incoming email to your, let's say, Gmail account. So the Gmail has to figure out whether it's spam or not spam. Okay, although it has to figure out many things, but let's assume that it has to do that. For example, pictorially, this is what it is, right? So you have email, which is basically text, right? And you have, there is an incoming email. You have to say whether it's spam or not spam, right? Of course, this is not a good representation because typically if you have numbers, it's easy to deal with. You can do a lot of arithmetics. You can use math as a tool to solve certain problems. So the first thing that you have to do in all of these, right, whenever you deal with machine learning, this is the first thing that we do. You convert this into numbers. That's what we did when we looked at the house price problem, right? We converted the house, whatever the features, we extracted features and converted those into numbers, right? For example, locality, I can say 0 to 1, right? Scaling. 1 means very good locality, 0 means something. So that's what you do. So in email, what do you do? So first thing is, when you want to convert this into numbers, whenever you have an email, you remove articles like a and also few other things, right? The, for. Well, this won't say whether it's spam or not spam, right? Do you agree? If there is the letter A present or not, it doesn't matter. Or article A and present or not, it doesn't qualify. The email doesn't qualify to be a spam or non-spam. So you can basically remove. Very easy, right? You just have to write a script that will remove all these. What to remove? Well, you have to list down all the numbers, right? So before that, the other thing that you do is, once you do this, you collect what is called bag of words. Okay. It's also sometimes called dictionary. The typical words that people use whenever they write emails, whether spam or non-spam, right? So you have this bag of words, typically of size, let's say 50,000. There are 50,000 words. So what you do is you take these 50,000 words. Okay. Let's say I say word 1, word 2, and so on. Word, let's say K. Okay, there are K words. K is 50,000. What I do is I have to, whenever there is an email, right? Of course, the first thing is I'll remove AN and all that. The second thing that I will do is basically I will count the number of times word 1 has occurred in the email. Let's say X1 number of times the word 1 has occurred. Maybe X1 is 0. And similarly, the word 2 has occurred X2 times, and so on. Word K has occurred XK times. So now I have converted an email into a vector, right? So this is how I write. It's K dimensional space, right? So I get a vector. This is called again features, right? You agree? So what is it that we have to do when we say that you have to design some machine learning algorithm to sort out whether an incoming email is spam or not spam? So there is an email. The first thing is that you do is you convert this into feature, right? Feature extraction. This gives me a vector which is x1 through xk, and this feature goes to an ML algorithm, machine learning algorithm, or right, which will give me whether it's spam or non-spam. Let's say -1 is for non-spam, +1 is for spam. This is the usual flow, right? This is non-spam. Okay. So this is how you do. So what people generally do in machine learning is, at least in academics, we basically ignore this, right? So ignore this part. You don't really care about what happens here, right? Many a times. So what we focus on is what happens here. Right? Once you have the feature vectors, so how do I do, classification, regression, and blah blah blah, right? So that's what we look at. Although, for example, you do a lot of signal processing to get the features, right? So that in itself is a subject which you will study in academics. But there are other places where you have to do a lot of, donkey work to get features, right? But not always the case. So now, what is the task here? The task is you have to take several, basically you have to find an ML algorithm. So again, it's a mapping, right? So I have to take a vector of size k, map it to either +1 or -1. So how do you do that, right? So can somebody tell me what is the intuition, or how do you go about doing this? Any guess? How do you solve this problem?
We will need some data to train on, first of all.
Right, so you need data. So what do you mean by data? When I write data here, I don't mean to write the emails itself, right? So I'll convert that email into a feature, right? So that will be my data. X1 is the feature extracted from email 1. And somebody should sit and read and figure out whether it's spam or non-spam. So this is basically -1 or 1. Okay, so the person who reads this email will, if he decides that it's a non-spam, then he'll put -1 or he'll put 1 there. Okay, so then you read the second, you extract the feature of the second email, somebody will read the second email, label it, and so on, right? So you have nth email, nth label. Okay, this is your data, right? So this is your data that you have. Okay, so what can you say about this data? First of all, this data is random. Do you agree? Do you agree with this?
Yes, sir.
Right? And typically, if you look at emails from different people, or at least similar people, these data or these random variables, in fact, this is a random vector, right? You have x1, which is a random vector, and a y1 is a random variable. So this will be what is known as IID, right? So, okay, those who don't know what IID is and all that, don't worry. Okay, it's very similarly generated data. Now you have IID random sequence, right? That means it will also have some distribution, right? The joint distribution of x and y of, let's say, x, y, right? In other words, the way this tuple x comma y is created is based on this random experiment, which is generated according to this distribution pxy of xy. So the point that I would like to make here is that there is another tool, right, called probability, which all of you have studied, right? So this is another very, very important. It's at the core of all data science. Okay, so this is a very important mathematical tool in order to understand data science. But this is something that I'm not going to cover. Okay, so maybe I'll briefly touch upon whenever it's required. But this is something that you have already studied in your second year, introduction to probability course. So I'm not going to give any. The treatment will be very, very less. Okay. So any questions? So probability is something that I don't touch upon. Okay. So you may have to take, if you want to understand more, you may have to take other courses. Okay.
So you said that the data was random. Did you mean that it is a random variable and it comes from distribution, or I did not
Yeah.
understand?
So for example, the way x comma y is getting generated, right? It follows some distribution. So it's generated according to some distribution, because you don't know who wrote the email. First of all, you don't know what was the intention, right? And so on, right? You don't know whether somebody who wants to spam, he has written the email or not. So there are so many randomness, right? So we can assume that somebody, this whole experiment, you can think of it as a random experiment where different people are generating different kind of data sets, right? Which is random, it follows certain distribution. Well, there are some philosophical questions here, but let's not get into that. So this is a reasonably good model which works well. Okay. So any questions? So in the next class, what we are going to do is we are going to look at this data a little closely and see how it leads to a neural network and subsequently another optimization problem. Okay. So there I will stop, discussing more about data analysis and so on. We will get into the mathematical aspects of this particular course. Okay. So I will stop here. Any questions? So tomorrow's class announcements, I'll do it tomorrow. I'll send an email by tomorrow afternoon, and I have to update you about the evaluation policy, which I will do tomorrow. Okay. So any questions, comments? The other question is, can we shift this slot? No, impossible, right? Or is it possible? Yeah, any questions? No?
Sir,
Yes.
do we discuss in more detail about these type of problems, sir? Like this mailing and movie recommendation.
Say that again. I couldn't hear you.
Will we in the future discuss about more of these problems, sir? Like
Yes.
okay, sir.
So you end up hopefully implementing one of them. I mean, the solution. Okay.
Okay, sir.
Don't worry. Okay. Any other questions? Well, we will give you most of the, for example, data cleaning or all that you need not do, but you will look at the algorithmic aspect, meaning solving some optimization problem or, coming up with an algorithm that solves some problem, these kind of things. Okay. Any other questions? No? If not, I will stop here. We can meet tomorrow again. Okay. Yeah. How many of you are okay with the online? I mean, just online. Which is better, online or offline?
So I feel the offline is better, but due to some issues, I cannot go to campus right now.
Okay. No, I think I was thinking of having a mixed mode, meaning I'll do the same thing in the class. Okay, that's better. The best thing would be to video record the actual lecture and then post it online so that the other people can watch and we can have an office hour. Okay, so I will also let you know about the office hours for this particular course tomorrow. Okay. Yeah. Okay, so if there are no questions, see you tomorrow. Thanks. Bye.
Hello, sir.
Yes.
Sir, regarding that, you told me to make some code or something, right?
Which one? Oh,
You told me to make some.
the pack and this thing, right? PCA.
Yeah, PCA, and then just some basics.
So we will maybe this week we'll share it with them. So I didn't plan to do that today. So
Okay,
I'll
okay, fine.
deviate it from my usual plan. Yeah.
Okay, fine. Sir.
Okay.
Yeah.
Okay. Okay. So thanks. Bye.